Hi, have you ever imagined how would it be if you could build your next mobile or web application while you are actually describing it? How would it be if you could do that within minutes without any manual managerial effort or a dedicated development team? In this video, I'm going to present you how our core framework from Zemius.com works, and we will create a fully functional API using voice control. Let's get started.
Alexa, start Zemius Builder.
Zemius Builder was started.
Start building a new API project using Serverless framework which supports English and Romanian languages and set English as default.
What's the name of the workspace where to add the project?
Shop application.
What's the name of the project?
Shop API.
The project was successfully created.
Now we have created the core configuration for an API which will use serverless and eventually will be deployed to Amazon Lambda functions. As you can see on package, we have some base dependencies for using Express and serverless. We have some configurations for internationalization based on what we requested from Alexa in the beginning. Also, the same locals JSON files were created. Alexa created for us an empty Git repository, so I will use it to commit every time just to be much clearer what was changed with every iteration. The next step would be to create a new database for our project. Alexa, create a new relational database.
What's the name of the database?
Shop database.
The database was successfully created.
As you can see, now we have some new configurations for our database. Also, in package we have some new npm dependencies like Kinex and MySQL. And it created a new config directory for our shop database which contains some helpers. Now it's the time to create new models. Let's add a new product model. Alexa, create a new model and add timestamps properties and primary key.
What's the model name?
Product.
What's the database table name?
Products.
The model was successfully created.
We have created a simple product model which only have created that and updated that properties without any custom properties or validations. As you can see, the locals and constants were updated as well. And we have a new model and a new DB migration. Now let's add some properties. Alexa, create a new required string property on product model and add a lorem sentence faker.
What's the name of the model property?
Title.
The property was successfully created. Can I help you with something else?
Create a new required float property on product model and add a commerce price faker.
What's the name of the model property?
Price.
The property was successfully created.
We have created two properties, title and price, and we will use some fakers like lorem sentence and commerce price, which are some helpers which we are going to use soon when we will have some environments in order to generate some fake data. Let's see how can we add a new validator on title property. Alexa, set a new length validator to be between 10 and 100 characters on product model.
On which property do you want to add the validator?
Title.
The validator was successfully added.
Meanwhile, the same files were modified by Alexa. In the migration script, now we have a maximum length set to 100. Also, the constants and locals were modified as well. A condition which checks if the length of the title is between 10 and 100 characters was added now for the product model. Let's create a router which only has the getAll and getById methods. Alexa, create a new router and generate getAll methods.
What's the router name?
Products,
What's the name of the model?
product.
The router was successfully created.
The corresponding logic for getAll method was added now, including the serverless configuration for getAll products. I'm going to show you how the router, controller and DAO looks like with this new method. I won't go into implementation details, but feel free to pause this video. Let's add now the getById method on products router and see how Alexa handles this kind of scenarios. Alexa, create a new method.
What's the router name?
Products.
What kind of methods do you want to add?
GetById.
The methods were successfully created.
We have created now the getById method for the same products endpoint. As you will see, the router, DAO and controller received more logic related to getById. Let's check it out. I won't go into implementation details, but feel free to pause this video. Now, the last step that we have to do is to create some environments like production and development in order to run the project. Alexa, create a new environment, generate 10 fake data rows for all models and create the Docker configuration.
What's the environment name?
Development. Now, as the environment was created, let's check what did Alexa actually modify on our source code. On package were added more scripts for this environment called development, for running the MySQL migrations files, seed files and for working with Docker Compose. In the same time, the environment was added to Kinect so it will be supported. The environment directory has an environment variable file which for the moment is populated with required data for running the Docker containers. We have the fake data generated for our model as we specified at the beginning with the faker params. The Docker Compose file has configurations for serverless, MySQL and MySQL migrations as well as phpMyAdmin, which is the default dashboard for managing MySQL databases. Let's run now the API. The API will run on port 3000, we will have a MySQL instance running on 3306 and the phpMyAdmin will run on 8080. Let's do a quick test on the API in the browser. The getAll products endpoint returns a list of products, each one having the custom title and price properties and the timestamps and primary key. Also, we have a getById endpoint as well. Thank you very much for watching this. If you like it, please follow us on Twitter or subscribe to our newsletter on zmuse.com.